Yeah, it's kind of tough.
but
All
I
right.
don't know.
Well, we're gonna get started today. So I think we pretty much have everyone in the class now. So today I put up the new schedule on Titanium, or not Titanium, on Canvas, if you guys saw that. So if you're on the homepage, I added the schedule for week 2 here. But the first thing I want to go over today is opting out of the textbook. So I had a few questions on that last class. So by default, the school is having you, they're like basically enrolling you to buy an online version of the textbook by default, which seems, kind of suspect. So if you want to opt out of that, I would recommend that you do so you don't get charged on September 8th, I think you're going to get charged. So if you log into the website and you look at my courses on the homepage, sorry. So you should see your textbooks for each class. So if I click on EGME 205, so this class, and we see this page is going to come up and it's going to say, do you want to opt out now? Oh, it looks like they just added this, read now. Or is that just for the textbook? Yeah, probably. So if you want to opt out, click on this and then you can select the reason that you have and then you can click opt out. So I haven't done this yet because I want to show my other class too, but I imagine once you click opt out, that's it. Have any of you done that yet for this class?
Yeah.
Yeah.
Just did it right now.
All right. So yeah, I would opt out because I think when are you charged? Last day to opt out is September 8th. So make sure to opt out because maybe you want the book and that's fine, but I'm gonna assume that a lot of you don't want to buy the book online. And you should do that for all of your other classes too. All right, so that's opting out. Next thing, we're going to be going over the first week a little bit in the beginning, and then we're going to finish the slides that we had. I've added a few more slides too, so say I updated the slides last night, and then we'll go over arrays later on in the week. So I'm planning to finish the chapter 1 slides today. We'll see where we get, and then we'll start chapter 2, which is arrays on Wednesday. Next Monday, we don't have class because of Labor Day, so make sure you don't go to class then. And I'm going to assign the first homework today, so I just need to basically touch up a few things, and then I'll post it sometime today. And then that homework is going to be due next Monday by 11:59 p.m. Oops. And then another thing, so I added a little announcement here. We're going to have the first quiz next Wednesday. So not this Wednesday, but next Wednesday. That's going to be at the end of class. So make sure you're in the class. And then I'm going to have the quiz on Canvas. It's going to be timed. Basically, it's going to be timed just so you're not encouraged to basically cheat. So you'll have a reasonable amount of time to do it, but yeah, you're gonna be doing it on Canvas, and it's gonna be at the end of class. So
You said it was going to be next Wednesday, correct?
yeah, next Wednesday. So yeah, not this Wednesday, but next Wednesday. All right, and so someone's asking, is MATLAB C++? It's not C++, and it's not really Python either. It's kind of its own language, and I'm gonna use that in quotes. If you ever talk to someone that's taking or majoring in CS, you'll probably hear them kind of like shit on MATLAB because it's not like a full programming language. So yeah, it's not really C++ or Python, but it's its own kind of programming language, but not really a programming language because it doesn't start counting at 0. So, when we do stuff, we're going to start counting at 1 for like arrays, and we'll talk about that later on, but most languages, they start at 0 to count. Anyways, that's a whole different thing now. So, yeah. Any other questions on, the homework or quiz or anything? Okay. All right. Oh, yeah. And then the homework, remember that that's being graded on completion. So I'm not going to grade that on, whether you got the problem right or wrong. I'm just going to grade it on if you completed it and put in some effort. So if I can tell you just, I don't know, put in really random stuff to each problem, then you're probably not going to get full points. But if I see that you put in an effort, then I'll give you full points. And the solutions for the homework, they're going to be posted right after it's due. So I'll probably post it, at like 12 a.m. And then, so you have a full day to look at those solutions before the quiz, so you can better prepare for the quiz. All right, so hopefully all of you have MATLAB opened up right now, because again, I want you to go along with me, and we're gonna have a few exercises throughout the class. But so the week 1 review. So we're gonna talk a little bit about this. So last time we talked about the command window. That's this main window that I'm in right now. And that's primarily where we're going to live for the first few weeks, or probably the first few months, really. And then we have the use of comments and suppressing comments, or I should have said suppressing output rather. But remember, I can put some comment in by using a percent sign. And that comment, it's not going to be, registered by MATLAB. It's not going to try to run a command if there's a percent sign. Then I can do, a equals 5. Then I can suppress the output by putting a semicolon. So I can run this, and a equals 5, that's stored in the workspace over here, but the output, the text output, that's not in the command window. So we can kind of, have a nice clean workspace here. If I didn't put a semicolon, if I just do like x equals 2, and then it's going to show me that text output in the command window. So someone has a question, where can we find the recorded class meetings? So yeah, they're on Canvas. So I'll go to there really quick. If you're on the home page for this class and you scroll down to the schedule that we have here, if you click on like week 1, then it'll show everything that's associated with that week. So it shows the schedule, shows any homework that we have, and then on the bottom for each day, I have the videos right there. So lecture 1, how to use the virtual computing lab, and then lecture 2 is down here. Okay. All right, so I'll go back to MATLAB. Okay, and then we talked about basic math operations. So most things, they work how we would expect. I can do 2 plus 2, that's going to give us 4. Multiplication, that's pretty much the same too. We use the star there, so 9 times 3, 27. And then I can do division, 9 divided by 3, that's 3. So remember, I'll use quotes again here, normal division that we do in our everyday life, that's going to use a forward slash. A backslash, that's used for solving primarily systems of equations. So that's something we're going to discuss in, I think, chapter 8. So that's pretty far down the line. All right, and then we have precedence. So we talked about that as well. So you want to make sure that whatever you want to do first, I would recommend putting that in parentheses. That's going to just ensure that it's being computed in the order you want it to be computed, and it's easier to read. And then we talked about some built-in functions. So there's stuff like trigonometric functions like sine of x, cosine x, tangent of x, stuff like that. And I mean, there's so many functions in MATLAB, I can't go over all of them, but we talked about some of the basic ones. So let's see what else we had. Formatting as well, we talked about that for a bit. I need to fix the slide. And stuff like pi. So anyways, we're gonna start out with an exercise, but first we'll talk about this week's schedule. So I talked about that a bit. We're gonna go over some more functions in MATLAB that are built in that we're gonna use pretty often. We're gonna talk about complex numbers, and then really we're gonna get into more substantial stuff for this class, which is arrays. So we're gonna have a little intro on arrays here, and then chapter 2, once we start that, that's gonna go into arrays in a lot more depth. Okay, and then we're gonna talk about polynomials, and then I also should have added here, we're gonna also have an intro to plotting as well. So plotting is also its own chapter, but we're going to have a very brief intro to plotting in this chapter. Okay, so I want to start out with an exercise here just to kind of refresh yourself for using MATLAB. So I want you to define two variables, so a equals 4 and b equals 20. And then on your own, complete the following basically math problem. To find z equals, and then a divided by b plus 5, where b plus 5, that's in the denominator, and then multiply that by 10 squared. And I double checked the answer this time. So the answer is correct for what I put here. It's minus 20. So I'll give you like a minute or two to work on this. Okay, so even if you're not done, that's fine. We'll go ahead and show you what to do. So I put in the code on the slide as well, but we'll just go through it now. So I actually did have an error, I guess. It should be a equals 4. So hopefully that's actually correct. So did you guys get it?
Negative 26, I think.
Okay, so I guess I messed up again on typing my stuff out. Okay, so sorry about that. Okay, so we'll go through it right now. Okay, so z equals a divided by, we'll do b plus 5, and then times 10 squared. The output, so yeah, we get minus 26.67. All right, so I even checked this. I thought I did, and apparently I didn't check well enough. All right, so yeah, we have a decimal right now, and we want to get a fraction, or let's just pretend we do. So from last time, remember we're going to change the formatting to a rational format. So we'll type in format rat. Then if I type z again, and we get minus 80 divided by 3. So if you did that on your screen, you should be getting the same thing now. So yeah, again, sorry about that mistake. I really got it right this time. Yeah. Question?
For some reason, I'm still getting negative 26.666.
So you typed in format rat and then you put in z again afterwards?
I didn't type format right.
Okay, yeah, so type that in. Okay, and then someone's asking if I prefer a decimal or a fraction. I don't really care. It could be either or, but I think sometimes seeing it as a fraction is just kind of easier to look at. But for a quiz or anything, I wouldn't care if it's a decimal format or a fraction. Or if I did, I would specify in the question. Okay, so I'm gonna go ahead and fix this slide afterwards again. So sorry, that was wrong again. And then we have one more here. And if I messed this one up too, that'll be pretty amazing. But work on this as well. So we're gonna define x equals 90 degrees and then y equals pi divided by 2. And then we're just gonna add that. So do a equals cosine of x plus sine of y. And make sure cosine of x, you're evaluating that in degrees. And then sine of y in radians.
Professor, how do you do the degree symbol?
So for that, it was kind of a little bit of a trick question, but all you have to do is x equals 90.
Okay. Thank you.
Mm-hmm. All right, so I'll show you what to do now. So hopefully all of you finished that. So we'll do x equals 90. I'm going to suppress the output, so I'll put a semicolon. And y equals pi divided by 2. We can just type out pi. And then we'll do a equals. So I wanted it in degrees, so we're going to do cosine d and then x plus sine of y. So by default, these trig functions, they're in radians. So that's why for y equals pi divided by 2, I'm just doing sine of y. While for x, we want to evaluate that in degrees, so I'm doing cosine d for degrees of x. Then we get a equals 1. And so I did have this slide at least correct. Okay, so pretty basic, exercises there, but we're not doing anything too complicated yet. So I finished off the last class talking about some of the common functions in MATLAB, but I just want to go over this again. So if we're typing out an exponential function where we want to do e, to some power, we have to type exp of whatever number we have. So we have like a equals 2. Now I want to do e squared. We just do exponent of a basically, and then we get our output there. For the natural log, so this is kind of weird. For the natural log, we have to type out log of x. So it's kind of, I guess, a quirk, but just remember to keep that in mind. And then for a regular logarithm like log base 10, we have to do log 10 of x. For inverse trig, we have to have a prefix for the function where we have a. So a stands for inverse. And then again, by default, that's going to be in radians. So if we want to do an inverse trig function in degrees, we do a, whatever the function is, and then d of whatever number we have. Okay. All right, so complex numbers. We'll talk about this a bit. To be honest, I haven't used complex numbers at all since I took this class, so I don't know how often you're going to be using it yourself, but probably not too often. So we can enter a complex number in 2 different ways in MATLAB. So make sure you're following along too, typing it out. So I'll do 1 minus 2i. And if I do this, then I'll just give us the output there, and that's fine. I'm going to change the formatting again. Okay, so if I change the formatting to short, it's going to actually show it a little bit, I don't know, I think it looks a little bit better like this, so we'll do that. And then I can also just do, I'll do C2 this time. C2 equals complex, so we're using complex now as a function in MATLAB. Now I can do 1, and then minus 2. All right, I don't know why it's giving us this error now. Okay, it shouldn't be capitalized. Okay, so capitalization does matter inside of MATLAB, so keep that in mind. And then we got the same number as C1. So C1, we just did that a different way where we had C1 equals 1 minus 2i, and that gives us the complex number. And then we did C2 equals complex, where complex is a function inside of MATLAB. Then for its arguments, we had 1 and minus 2. Okay, I'm going to clear that. So to define a complex number, we do not need to use an asterisk. I can never say that word, but we don't need to use a star basically. So if we want to do C1 again, so C1 equals 1 minus 2i, and we get that complex number. But if you do something like C1 equals 1 minus 2, and you do times I, that's going to be a different output. So if we look at this example here in the bottom, we do y equals 7 divided by 2 times I, and we compare that to x equals 7 divided by 2i, then we have 2 different results. So up top here, we have it's positive. So what we really have is 7 halves, and then we're multiplying 7 halves times I. While on the bottom, we have 7 divided by 2i. So that's going to give us the minus sign there. So make sure you're careful that you're basically not multiplying this imaginary number I. And then, yeah, we just see the output right there. Okay, operations with complex numbers.
So for first y, where it's dividing 2 times I, what if we put that in parentheses? Would it be the same as the divided by 2i?
I don't think it would be, but we'll try this out right now. So you mean doing this, right? 7 divided by 2, and then times I? Is that what you mean?
Yes.
Okay. So yeah, that still will be positive because we're basically taking 7 halves, and then we're multiplying that by the imaginary number, but that's not really what you want to do.
Okay.
So yeah, just make sure if you're using a complex number, you just type out the I. So just like the bottom example where we did 7 divided by 2 and then I. Okay, so operations with complex numbers, for the most part, they're going to work how we expect. So addition and subtraction, they're going to be pretty simple for us. So if we do x equals 3 plus 2i, and I'm going to suppress that. We do y equals 2 minus 4i. If I want to add these, so w equals x plus y, then it's basically going to be added, like we would expect it to. So we have basically 3 plus 2, that's going to be 5. And then 2 plus negative 4, that's going to give us negative 2y. Okay, so we get that. That's pretty simple. And again, it's going to be the same thing for subtraction, but I want you to do this on your own. So I'll give you like a minute or two for that. Okay, so if I'm not giving you guys enough time to, then feel free to tell me I'm not, but hopefully you finished. So we have p equals 3 minus 8i, and s equals 10 minus 9i. And then if we want to do p minus s, and we get negative 7 plus 1i. So we have 3 minus 10, that's going to give us negative 7. And we have negative 8 minus negative 9i, and that's going to give us a positive 1. Okay, so multiplication, I don't know about you guys, but I didn't even remember how to do this initially. Well, I took a guess and it was correct, but basically if we're multiplying complex numbers, we have to do FOIL. So I don't know when the last time is you've multiplied complex numbers, but for me, I don't know. I don't think I did it at all in undergrad at least, so it's quite a while. But yeah, all we have to do is FOIL for multiplying complex numbers. So if we have s equals 5 minus 9i, and we have t equals 3 plus 7i, and we multiply them, so z equals s times t, then we're going to get 78 plus 8. So we can kind of break this down where we actually write out the math just so we know that we understand what's going on here. So for multiplying s times t, then we have doing FOIL basically. 5 times 3, that's 15. Then we have 5 times 7i, so on the outside here, 5 times 7, I. And then on the inside, we have negative 9i times 3. And then the last ones, we have negative 9i and positive 7i. So we have 15 plus 35i minus 27i. And here we have positive 63. So we have negative 9i times positive 7i. Basically, that gives us negative 63i squared. And remember that I times I, or I squared, that is a -1. So because we have then two negatives, we're going to get positive 63 right here. And if we simplify some more, we get C equals 78 plus 8I. Okay. Any questions on that? Okay. All right. So last thing here, we have division. And again, I don't know about you, but I actually did have to look this one up because I haven't done it in so long. So division is a bit different too. Well, first I'm going to write this out in MATLAB. So we have U equals 3 plus 2I. Okay, there we go. U equals 3 plus 2I. V equals 4 minus 3I. And then if we want to do is Z equals U divided by V, then our output, I'll change this to a fraction because that's what I had it as. So I'll do format rat. And if you see here on the slide, what I did is format rat, and then I did a semicolon, and I put in Z. So that's all in the same line. But basically that code, it's the same as writing that on 2 lines. So I just wanted to save some space. So I did format rat semicolon. That's going to finish that command that I just put in there. And then I put in Z just so I can, show the output for Z. Okay, so if we break this down now, if you want to divide complex numbers, the first thing you have to do is multiply by the conjugate here. So the conjugate in the denominator. So for us, we're doing 3 plus 2i divided by 4 minus 3i. So we need to multiply by the conjugate in the denominator. So we're doing all of this multiplied by 4 plus 3i on the top and then 4 plus 3i on the bottom. And now what we have is we're just multiplying complex numbers in the numerator and in the denominator. So we're going to do FOIL once again. So we get 12 plus 9i plus 8i minus 6. You guys know how to do FOIL. And on the bottom, 16 plus 12i minus 12i plus 9. And simplifying, we just get 6 divided by 25 plus 17 divided by 25i. So the imaginary number, that's equal to the square root of -1, if you can remember that from probably high school. But I would imagine for most of the stuff you're going to be doing in your classes, you're not going to be using it. I think the only time I used it was in a math class and in circuits. So yeah, right now we're just using it for practice. For actual coding that we're going to do in this class, we're probably only going to use it right now, to be honest, or in a plot. But you might see it in some, if you're doing it in some class like circuits, you might need to know how to do it in MATLAB. All right, so any questions on anything we've gone over so far? Okay, so we're going to start arrays now. And to be honest, I think talking about arrays is more interesting than the stuff that we've talked about so far. Okay. All right, so I guess I would like to first know, have any of you taken linear algebra yet? I don't think you have.
I have.
Okay.
Oh, yeah.
I'm in the
Okay,
class
so-
right now.
Okay. Yeah, there's actually more of you than I thought that took the class. So even if you haven't, that's fine. We're gonna talk about a pretty basic, at a low level sense right now. So it could be too complex, but for linear algebra, a lot of what you're going to deal with are arrays and matrices. So, and you actually might be talking about this in 225 as well, at least for a vector. Okay, so basic definition: an array, it's a collection of numbers assigned to a variable. So you'll often see people talking about arrays in MATLAB. So that's all this means, that there's a lot of numbers assigned to some variable. So that can be a row vector, which you see on this slide here, or it could be a column vector, or we can have a matrix, which is a combination basically of row vectors and column vectors. So the first thing we're going to do here is define a row vector. So like the name would imply, we have an assignment of numbers or a collection of numbers, and they're in a row. So I can do A equals, and then you're going to use a left bracket. You have to use a left bracket to, or brackets really in general, to make an array. So we'll do A equals left bracket 3, 0, 4, 7. And then we're going to finish it off with a right bracket. And then if we press enter, then we get this output right here. All right, so if I double click on A in the workspace here, then that's going to open this spreadsheet up. And again, we just see what we just saw. But once we start defining, really big matrices, then this tool is going to be pretty valuable to us. Okay, and then to define a row vector, we can either do it how we just did right now, where we just typed in 3047 with a space in between each number, or we can use a comma. So now if I do B equals 3, 0, 4, 7, and then I close it off with a right bracket, and then I press enter, it's going to be the same exact row vector that we just defined. Yeah, one space between each number, yeah. So I'll also do C equals 3, 0, 4, 7. So this time I don't have any spaces in between the numbers, but I do have a comma. So if I do that, that's again going to be the same row vector. So for you, it's really a matter of what looks best to you. So most often for me personally, I just put a space in between each number, but some people prefer to put a comma. So sometimes that helps with the readability. Okay, so someone got columns 1 through 2 and columns 3 through 4. So you typed it out exactly the same. I'm trying to envision what you mean by columns 1 through 2 and columns 3 through 4. Okay, so someone's saying it's the same thing. Yeah, I'll need to see your output on your screen because I'm not really sure what you mean by columns 1 through 2. But actually, I think I know what you mean right now. So yeah, we have 4 columns in this row vector. Sorry, someone was talking?
Yeah, so it's just saying which column the value goes to because the screen might be a little shrunk or something.
Okay, yeah. So yeah, yeah, you might see that, yeah, if you're on a small monitor, but in this row vector, you'll see here it says it's a 1x4 double. So that means we have one row, which is this, what I have highlighted. And then we also have 4 columns. So we have, here's one column here, here's the second column, here's the third, and then here's the fourth one. Okay, so hopefully that makes sense right there. So we'll define a new row vector. We'll do x equals, 3, 0, 9, 8, 2. So now I have 1, 2, 3, 4, 5 numbers. So now I should expect a 1x5 row vector. That would be the terminology that we're going to use. So if I press enter and we get the output, you'll see it like this. And I can do size of x. And then it says 1, 5. So what this means is we have one row and we have 5 columns. Okay. And now for a column vector, to do this, we're going to define it a bit differently. So if we want to define the column vector below, we're going to use a semicolon now to suppress or to basically terminate each row. So if I want to define this column vector, I'm first going to do b equals, and again, we're using a bracket. We always have to use a bracket. So B equals left bracket, then 3. We'll type in a semicolon. That's going to end that current line that we're on. So B equals 3, semicolon 0, semicolon 4, and semicolon 7. Now, if you press enter, you should get an output that looks like this. Okay, so in this case, put in the chat what you think this size would be. If we type in right now size of B, what should we get? So if you're not in linear algebra, then maybe you don't know off the cuff, but yeah, so we're going to get a 5 by 1, or a 4 by 1. So we have 4 numbers here. So if we type in size of B, then we get 4 and then 1. And yeah, just like someone said in the chat, we have 4 rows here. So we have 1, 2, 3, 4 rows, and then we have 1 column. So if I go to the workspace and I double click on B, double click on B, then it says 4 by 1 double. So we have 1, 2, 3, 4 rows, and then that 1 column. All right. And then just like with the row vector, I don't need to have a space. So I could do C equals 3, semicolon 0, semicolon 4, and semicolon 7. And if I press enter, it's going to be the same exact column vector that we just had. So again, the readability is up to you. Now, there is another way that we can define a column vector. So I'm going to clear everything. So this might be, it's basically a more visual way to define a column vector, or later on for a matrix as well. So I can do A equals left bracket. Now if I press enter, it just puts me on the line below. So because I put that left bracket, it knows that I don't already want to run some code. It's basically starting some operation, and until I terminate the operation with another bracket, it's not going to do anything. So I'm going to do the same column vector that we have on the slides. So now I'll type in 3, and then I'll use a semicolon, then 0, semicolon 4, semicolon 7, and then I can close this out with a right bracket right there, and then we get that output just like that. Okay, so you can do it this way, but personally, I don't like doing that because it's going to take up a lot more space. So I would rather just do it all in one line. Okay, now we're going to get to a matrix. So again, a matrix is going to be essentially a combination of row vectors and column vectors. So for this matrix right here in the slide, I have 2 rows. So here's 1 row, here's another row, and then I have 2 columns. So here's 1 column, and here's another. And that's called a 2 by 2 matrix. Or a lot of times you'll see it's an M by N matrix. So M, that's going to denote the rows that we have, the number of rows, and N denotes the number of columns that we have. So if we want to type this into MATLAB, I'll do capital A, and I'm using a capital A because that's the general convention that we have for matrices. So if you're defining a matrix, you're going to use a capital letter. That's not, a set in stone rule, but it's something that's often recommended, or basically it's the convention that's used. So to do this for the top row, we're essentially defining a row vector, right? So we're doing A equals 3 and then 0. Then if I want to do the next row, I'll do 4 and 7. And you'll see that I suppressed I terminated the first row right here. So I did A equals 3, 0, semicolon to terminate that row. And then I'm putting in a new row, 4 and 7. If we do that, then we see the output right here. All right, if I double click on A to open it up, now we see it's a 2 by 2 double. Really, it's a 2 by 2 matrix. So we have, again, 2 rows and then 2 columns. Okay, any questions so far?
You could have also put commas between the 3 and the 0 and the 4 and the 7, right?
Yeah. Yes, we could do that right now. So I could do b equals 3, comma 0. And that's going to make one row vector right there. And then I'll terminate that row, and then I'll do 4, comma 7. And then we get the same matrix. So really a lot of this is up to you, right, for how you want to format it. But, you know, for me personally, I don't really like having commas, but you might, and that's totally valid. So you can use commas if you want. All right, and then I'll also show you doing the more visual method to make this matrix. So I can do b equals, we'll start at the left bracket. Then I can do 3, 0, and then put a semicolon. That's the top row. And I can do 4, 7. And then I'll terminate it with a right bracket. And then there we have the same exact matrix again. Okay. All right, so now we're going to do adding arrays. So again, if you took linear algebra already, then it's going to be really familiar for you. If you haven't, then it's still not too complicated. So you should be able to follow along here. So we're going to define two row vectors right now. Okay, so we'll do C equals 2, 0, 4, 5. So that's just one row vector right there. And then D equals 3, 3, 9, and 2. So we can open these up. So here's the row vector C, and here's the row vector D. Close out of that. And then we can add these row vectors. So all we're doing here is basically adding the values that correspond to each index in that row vector. So we're doing 2 plus 3, 0 plus 3, 4 plus 9, and then 5 plus 2. And then if I type in E and I want to see the output, then we, of course, see 2 plus 3, that's 5, 0 plus 3, that's 3, 4 plus 9, 13, 5 plus 2, 7. So pretty basic. Then we'll do, okay, I guess I skipped some stuff here, but we have subtraction. That's going to be the same kind of idea. Actually, I think that's later on. No, it's not. Okay, so subtraction, that's going to be the same though. So if I do F equals, we'll do D minus C. So if I do F equals D minus C, then that's doing 3 minus 2, that's 1. 3 minus 0, that's 3. 9 minus 4 is 5. And then 2 minus 5, negative 3. And then multiplying and dividing between arrays, we're going to talk about in chapter 2. So we're not going to get to that right now. We're just doing some really basic operations for the arrays. All right, any questions on how to define a row vector or a column vector or a matrix? Okay. All right, so an evenly spaced array. So sometimes you want to make an array that's evenly spaced, and you're going to do this actually quite often. So the main, I guess, or the most often time you're going to want to do this is when you're defining an x domain for a plot. So if you want to plot, something like sine of x, you need to make an x domain for that plot. So you'll do something like 0 to 10. So the syntax for this is some variable that we're going to define. That's going to be equal to the first value that we want. So like 0. The step size we want, we'll talk about that in a second. And then the last value that we want, which would be like 10. So everyone in MATLAB right now, type this out. So I'm doing x equals 0, and I'll put a colon, 1, and then a colon, and then 10. So that's going to define a row vector that starts at 0 and goes to 10. So in the middle here is 1, and again, that's the step size. So we're going to start at 0, then we're going to go to 1, and then 2, and then 3, and then so on till 10. So if we press enter, then we see something like some of you were talking about earlier. It's going to say columns 1 through 8, it'll show all of those values, and then columns 9 through 11, all of those values. So it's only doing that because it doesn't have enough space to put it all in one line. Or we could open it up again in the workspace here by double clicking, and then we can just scroll through and see everything like that. Okay. So I kind of already, some of you already might have seen it when I was in the workspace here, but we're going to talk about the length of a vector. So the length of a vector is going to be the amount of elements in that vector. So for this vector x here, if we type in length of x, which is the syntax we're going to have, then it's going to give us 11. So we have a row vector starting at 0 and going to 10. And obviously, since we're starting at 0, we're going to have 11 values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values here. Okay, so we'll do another one here. We'll do x equals 0, and we're going to do x equals 0 to 10 again, but this time we're going to change the step size. So I'll do x equals 0.01 to 10, and I'm going to suppress it this time. So in this case, we're going to have a lot more values because our step size is smaller. So if I press enter now, and I look at the workspace, we have a 1 by 1001 double. So if you compare that to a 1 by 11 double, obviously it's a lot larger now. So we're starting at 0, and then we're going to 0.01 to 0.02, and so on until we get to 10. All right, and then, so the purpose of doing this is basically to have a smoother plot. So we'll see that once we get to making a plot later today. Okay. So any questions on defining a row vector this way? Okay, so this is basically just going to give us a more fine degree of control for how we make our row vector.
So you said other languages start counting at 1 and MATLAB starts counting at 0?
Flipped. So most languages, they start counting at 0 and MATLAB starts at 1.
Oh, okay.
Just
Because I have to.
this row vector, I defined it to start at 0.
Oh, okay. Okay, makes sense.
Mm-hmm. Yeah, that's you know, I guess it's good to know that other languages start at 0 to count, but it's not going to be, you know, any issue for this class. It's just a difference between the two.
Okay.
Okay, so we just talked about this too. So if we typed in the length of x, that would give us 11. Okay. And the length of x, that'll be something that we do pretty often where we want to find the length of some array, but again, we'll talk about that in more depth later on once we start chapter 2. Okay, so now we're going to define an array in a different way. So sometimes you might know the starting point that you want, like 0, and you might know the end point you want, like, let's say 50, but you don't know the step size that you want. Okay, so we can know our start point, our end point, and how many elements that we want, but not the step size. So for me, I used this when I was using or doing a project last semester for one of my classes. I had to make a mesh basically. So I had to make some mesh, which might sound a little abstract now, but I had to make a mesh for some geometry, and I had to use a given amount of points. So I had to do, I think it was like 500 points, but basically if I do x equals 0, or if I wanted to define a row vector from 0 to 10, and I wanted 50 elements in there, then we're going to use the linspace command. Okay, so we'll type in x equals linspace and then 0, comma 10, and then 50. So I'm going to go over the syntax right now. I'm going to clear this really quick. Okay, so we'll do x equals linspace, and then we see this dialog box come up as well. So we can define our first value x1, and then our second value, or the last value, x2. And then we have a different option as well. So we can stop using linspace right there, or we can use a different version, or we can add another argument to this command here. So we can add how many points we want. So I'm going to show you the difference right now. So we'll do x equals linspace 0, 10. Okay, so if I type that and you look at the workspace on the right, it shows x is a 1 by 100 double. So let's double click that. That just means we have a row vector with 100 columns. So I can do size of x. Then we see we have one row and 100 columns. Or with the command that we just learned, length, I can do length of x, and now it's going to give us 100. Because remember the length command, that's going to give us the amount of elements in a row vector or in a vector. Okay, and then the other way we can use the linspace command is we'll do y equals linspace 0. So we're going to start at 0, then comma 10. I want to end at 10. And then I can also type in this case, we'll do 100. That's going to mean I want to have 100 elements in this row vector. So now if I do size of y, then this is also one row and 100 columns. Okay, so they're the same, but sometimes you don't know the step size that you want. So you kind of, use this kind of format here where you do like x equals 0.1 to 10. And in that case, it's giving us 101 values because we started at 0. But basically, yeah, sometimes you might not know that step size. So in that case, you would use the linspace command. It'll be easier to define the vector that you need. All right. Any questions on linspace? These commands right now, they might seem kind of arbitrary. Like you might think, when am I ever going to use that? But once we start using more or doing more examples that add context, then I think it'll make more sense to you. Okay, so now we'll talk about finding a value at a specific location. So this will be something that you do pretty often as well. So let's define an array here. So I'll do m equals 0. I'm going to use a step size of 0.1. And then we'll do to like, I don't know, 235. Okay, so on the right here, we have a 1 by 23,501 double. And this is a good opportunity to show too why we suppress stuff. So if I didn't put a semicolon here and I press enter, that's like totally cluttered now. Now I have thousands of rows in my command window. Still scrolling up, still going. All right, so yeah, you can see why you wouldn't want to do that. Now we can just type in CLC and we can clear that. Okay, so again, so sometimes we're going to want to find the value at a specific location in an array. So if I want to find the value at, I don't know, the 57th element in here, what I can do is type in, I'll do 57th, just meaning that's the 57th element. And I type in m and then 57. Okay, it doesn't like that expression there. Oh yeah, you can't start, see, I forgot this. You can't start a variable with a number in MATLAB. So they want you to use a letter. Okay, so in this case, we can just type in th, and that's going to give us the value at that 57th element. Okay, I'm going to clear the screen. Okay, hold on just a sec. I need to redefine m. Okay, there we go. And then I'm going to change the formatting here to short. So now we have a decimal. Then if I do 57 again, this is saying that the 57th element, that value is 0.56. So right now we can confirm that. We can go to the workspace here, double click on N, and I can scroll through and I can go to the 57th element. And then we see that value is 0.56. So that matches up with what we just computed inside of MATLAB. Now, hopefully you can see that it's a lot more tedious to go in the workspace, open that up, and then go to whatever value that you have. That would take a lot of time if you had to do that for, imagine if we did that for, 10,696, that would be annoying to go through each time. So it's a lot faster to just go in the command window and specify with code the element that we want to look at to see the value for. All right, so if I want to do, the 8,334th element, let's type an element, m equals 8,343, I forget what I just said. And then we can see that output. So the value at 8,343 is 83.42. Okay. Any questions on finding values at any location?
For the format short, could you have put like the semicolon and then 57 next to it?
Yeah. So we'll do that right now. We'll do format short, then semicolon, then we'll do 57, or we'll do something new. So we'll do, I don't know, m equals 234, and then we get that output right there. All right, any other questions? Okay. All right, so now I have an exercise for you guys. So in MATLAB, define the following. So you're going to generate a domain from 1 to 30 with 200 elements. Then define a variable length to find the length of the domain. Then define a variable a to find the value at the 57th element in that vector. Okay, so I'm going to give you a few minutes here. So if you want to look at the slides, you can go ahead and do that as well. Pull it up on your computer. All right, so I'm going to give you guys like another minute or so. It's hard for me to judge if everyone's done or not in this virtual environment, but give you another minute or two.
I have a question. For the domain, can it be like either like X, Y, Z type
Yeah.
thing, or just any like, okay.
Yeah, you could do any variable.
Excuse me, Professor, real quick. So like when we were doing the other domains, like n is equal to 0, and then the number in between, and then the final number. In this case, it'd be the same, right? So I'd start off with 1, 200, then 30, or
You're gonna do the first number that you want, and then it will be the last number, and then the amount of points. Okay, so we'll show how to do it right now. So hopefully you guys are done, or at least you got some part of this. So we want to generate a domain from 1 to 30 with 200 elements. So in this case, you could do the math or something to figure out the step size, but you might not know the step size right away. So we're going to use the linspace command. So we're going to do linspace. I want to start at 1. So I'm going to type in 1. And then you see right here as well. So we're going to use this command right here that I'm going over. So linspace x1. That's the first number that we want. So we'll type in 1. And then it wants us to type in the last number for the domain. So we'll type in 30. And then n, that's going to correspond to the amount of elements that we want to have. So I'll do linspace of 1, comma 30, comma 200. And then if we look over on the right in the workspace, x is a 1 by 200 double, or it's a 1 by 200 row vector. Okay, and then I told you to define a variable called length to find the length of the domain. So that should be 200. Oops, x. So let me type in the length here. And yep, the length is 200. So we could look over in the workspace and we could see that x was a 1 by 200 row vector. So we could know the length that way just by seeing it here. But if you're writing a script or something, and you need to know the length for a lot of different arrays, and you want to do it very, very fast, do it like, an iterative process, then it's going to be beneficial for you to basically automate this using code where you can just type in, find the length of some array, and you don't have to look over by yourself in the workspace here. So once we get to scripting, I'll show you how that looks, and it's going to make that process a lot faster. Okay, and then I said to define a variable a for the value of the 57th element in the vector. So we just saw how to do that in the previous slide. So we'll do a equals x and then 57. So this is saying, look at the row vector x and then give me the value in the 57th element. And that's 9.1608. And we can confirm this visually if we want. We'll open up the row vector x. We'll go to the 57th column. And we see that that's 9.1608. And that matches up with what we just typed out. Okay. Any questions on that exercise? Hopefully it kind of gave you a little more context. I like saying the word context, but hopefully it gave you some context to the commands that we're using here. Okay. All right, so now we'll talk about polynomials. So you might use this a bit more than complex numbers, but again, it's not something that's used too often. At least I haven't used it that often. So to create a polynomial, we're going to make a row vector. And it's going to be created from the highest power to the lowest power. So it's going to go from left to right, from the highest power that we have to the lowest power. So if we want to create this polynomial here, 3x to the third plus 5x squared plus 7x plus 2, and we're going to define this row vector, polypocket. So poly underscore pocket equals, and because we want to define a row vector, we're going to start it by using a left bracket. So we'll do 3. I'm going to type in a space here. You can use a comma. So 3, 5, 7, 2. I'm going to close it off with a right bracket right there. Then if I were to press enter right now, then we just see that row vector right there. So all we've done right now is define a row vector. And it's not, it is a polynomial, but as we see it right now in MATLAB, it's just a row vector. But if I want to, analyze this polynomial, like if I want to find the roots of the polynomial, then I'm going to use a function, in this case, the roots function. So I can do roots of polypocket. So I can type out poly underscore, and then right there, I just tabbed over. So I didn't talk about this in the other lectures, but if I start typing out polypocket, and at this point, if I'm lazy and I don't want to type out pocket, I can just press tab. And MATLAB is smart enough to know, okay, I think he's trying to type out polypocket. So that can, save some time. Now if I press enter, it's going to give us the roots of our polynomial up here. And so remember the roots of a polynomial, that's going to be when our function f of x it has a value of 0. So remember that. Okay, so I think it's pretty basic, but again, the main thing is to memorize or remember that we're starting from left to right and it's going from the highest power to the lowest value or the lowest power. Okay, so a more efficient way to write the code, we could write all of this on one line. So if I want to, let me clear this out. If I want to find the roots of some polynomial.
Excuse me, Professor, real quick, just a quick question. Is it possible to do multiple polypockets? Is there a specific way to distinguish them? Or would I have to clear everything again and then restart it?
So you're saying you just want to find multiple polynomials?
Yes. Or
Yeah,
just...
you can just use whatever variable you want to use.
Oh, okay.
Yeah, so I'll do a different, I did polypocket. I don't know why, I just thought of a polypocket.
Okay.
So we could do like W equals, we'll do 5, 3, 9, 2. And then in this case, that's going to be 5x to the third plus 3x squared plus 9x plus 2.
Oh, depending the numbers is the root that it... Oh, okay.
Yeah. So if I type this out, again, right now it's just a row vector. But if I want to find the roots for this polynomial, I'll just do roots of W, and then we get the roots like that. But if we want to be more efficient with our code, I shouldn't say efficient. If we want to be more compact with the code, I can just do show me the roots for some polynomial. So we have roots, and right here we have a left parentheses. And now I need to put in the polynomial that we want to look at. So I need to use a left bracket now. We can do like 8, 9, 2, 3, 7, 8. I mean, it doesn't matter. Now we need to close off this polynomial with a right bracket. And we have to close off our function roots with a right parenthesis. Now if I press enter, it's going to give us the roots for this polynomial right there. Okay, any questions on that?
What do we use polynomials for?
So we might actually basically just define a polynomial at some point and plot it, but that's really it. You're not going to do it too often. Okay. Any other questions? Okay. All right, so file types. We'll talk about this. Let's see how much time. We only have 5 minutes left, so we might just get started on plotting today. Probably not. So we'll start on plotting next time, which I think is going to be a lot more exciting than the stuff we've done today. I think today maybe dragged on a bit with the arrays, but it'll get it better, at least with plotting. Okay, so file types. We've talked about this a bit before, but just to refresh your memory, we have two file types in MATLAB. So we have a .m file. That's going to be for function files, which we'll talk about in chapter 3, and script files. So if we want to make a script, again, we go on the top left here and click on new script. And then we can just start, writing out whatever script we have. And then if you were going to save that script, then you would see that it's a .m file right here. Okay, and then a .mat file, that's for the workspace. So that's here on the right, the workspace right here. Sometimes we might want to save all of those variables. So we can go on the Home tab here, and then there's an option to save the workspace right there. And then we can save it, and by default, it's a .mat file right there. So you're not going to save the workspace too often. If you're running a script file, you're not going to have any need to do that because your script will be able to define those functions, and then they're going to show up in the workspace. But if you're not writing a script file, so like what we're doing in this class, at least so far, we can save the workspace if we want to use all of those variables again in some other session. So we could save it, and then we could open it by basically going in our folder here on the left, and we can open up that workspace file, and then it would show up right here. Okay, so I can show you this right now. So right now we just have two things in here. You can go to Save Workspace, and so I'm just checking I'm in the right folder. Okay, I'm going to call this Workspace. Press Save, and then right now it showed up here in our current folder on the left. So I'm in the script file. Okay, so I'm going to clear everything right now. So now the workspace, it's empty. There's nothing in there. But again, let's pretend, I came back at a different day and I wanted to open up all of those variables from that workspace. I can just double click on here, and you'll see in the command window, it loaded that file. And now the variables are here on the left. So if I type in W, then there's that row vector that we just defined. Okay. All right, so we're basically out of time here. We just saved the workspace. Linear algebra, we already talked about this. We're going to use the left division operator, the backslash, to solve a system of equations. We'll talk about that once we get to that chapter. And then making a script file, we talked about that. We just go up here in a new script. That's useful when we want to basically change a lot of the variables that we have, or we want to go back and edit it quite a lot. And we covered all of that. And debugging, we'll briefly talk about this next class, but we're basically out of time here. So if you have any questions on today's class, then stay on the call and you can ask me. But otherwise, next class, we're going to get started on plotting, which will be more exciting. I think that's my favorite part of the class. So we're going to get started on plotting next time. Remember, I'm going to assign the homework later today. I'm going to upload it after class, sometime after class. I don't know when, but I'll upload that. That'll be due next Monday by 11:59 p.m. And then not this Wednesday, but next Wednesday, we have the first quiz. And that'll be in Canvas towards the end of class. Okay, but that's it for today. So I'll see you guys on Wednesday.
Thank you, Professor.
Thank you, Professor.
Yep, have a good day.
See you, Professor.
See you guys. Yeah, so you can just stay in the column in, and then I'll show you how to save the workspace.
Professor, quick question. So in the same thing when we did the practice problem for the domain and everything, we could have used element. We could have used element as well, right? In that case, to find.
So I'm trying to go to it right now. So this problem here.
Yeah.
Yeah, you didn't have to use the linspace command. You could have used the other method, but you would need to know that step size ahead of time.
Okay, so we can only use element unless we know the step size.
Yeah.
Okay.
So here, I'll just show you really quick. I'll do linspace 1, 3200, let me do x equals. I forgot to suppress it, whatever. So we see on the left here, we have x equals 1 to 200. So, I can look at the step size now. So I could do 1.1457. If it was a more complex step size or something. And then, so we have that. That's the step size. So if I wanted to find a new variable, y equals, and so we're going from 1 to 30. Okay, so 1, 0.1457 to 30. And then you see it's the same length right now. So they should be the exact same. And yeah, they are. So here we did both methods, but I didn't know that step size ahead of time. So I used the linspace commands instead.
Okay. Okay, thank you so much.
Okay, so there's a question to see how to save the workspace again. Okay, so I'm gonna actually clear that variable. We don't need that. Okay, so right now we have W, X, and Y. That's in the workspace. So you want to make sure that you're on the Home tab here, and then we can click Save Workspace. Let me go back to the slide too. Okay, so there are two methods. You could type in the command window to just save and then whatever file name you want and then specify that it's a .mat file, but I prefer just to go on this Home tab and press Save Workspace. So this will pop up and it's already a .mat file for us. So I'll call this example.mat and then I just press save. Okay, and then on the left here, because we're in this current folder, it's saved to this folder. So let's pretend I was somewhere else. So you might not be in the right directory right now, but so right now I want to go back to where I just saved that file. So I'll go to, for me, 205, lectures, chapter 1 intro, and then it's right here. So now all I have to do to open the workspace, let me first clear it from our session so you can see. So the workspace, there's nothing in there right now. If I go on the left in this current folder, I'll just double click on it. And now just loaded that workspace up for us. You can see it on the right too. So does that answer your question for how to save it? Okay, cool.
Professor, and real quick, the homework you said was going to be given this Wednesday, or is it already on Canvas today?
I'm gonna upload it sometime today.
Okay.
Yeah.
Okay, thank you so much, Professor. Have a good day.
You too. All right, any other questions?